Hello everyone, my name is Anjali. Now I am going to discuss about the topic called graphs. The content of the video is Introduction to Graphs, difference between trees and graphs, graph terminology and representation of a graph. Let us move to the introduction to graphs. First of all, what is graph? A graph is a nonlinear data structure. It is a collection of nodes or vertices that connect pair of nodes. This data structure is used to represent relationships or connections between different entities. Introduction. Graphs are fundamental data structure that represent relationships between a collection of items in a graph. These items are called vertices and the relationships between them are represented by edges. Graphs are versatile and find applications in various domains, including computer science, social networks, transportation systems, and more. Graphs can form cycles. G equal to V comma E, where V is the vertices and E is the edges. A graph is said to be a directed graph if all the edges in the graph are directions. That means in a directed graph, each edge has a specific direction, indicating a one-way connection between nodes. If there is an edge from A to node B, it doesn't necessarily mean there is an edge from B to A also. Undirected graph. A graph is said to be undirected graph if no edges have direction. Clearly, we can see the example and you will understand betterly. First, see the definition. A graph is said to be the undirected graph. There is no edges have the directions. That means edges have no specific direction and the connection between nodes is bidirectional. If there is an edge between nodes A and B, it implies there is also an edge between B and A. Let us move the example to understand better. It is the directed graph. A graph has nodes 1, 2, 3, 4. 2 to 1 is the direction and 3 to 2 is the direction and 4 to 3 is the direction and also 1 to 4 is the direction. So it contains all the edges have direction. Now let us move to the terminology of a graph. First, what is vertex or what is node? A fundamental data element representing a pane or entity in the graph is called vertex. Edge. A connection between two vertices is called an edge. Directed edge. An edge with a specific direction indicating a one-way connection from one vertex to another vertex. A graph is said to be a directed graph if all the edges have the direction. Undirected edge means an edge with no specific direction representing a bidirectional connection between two vertices. A graph is said to be unidirectional. It contains no edges have directions. Adjacent nodes. Nodes that are connected by an edge is called adjacent nodes. Degree of a vertex. The number of edges connected to a vertex in a directed graph, vertices have an degree number of incoming edges and number of outgoing edges. It is called a degree of a vertex. In graph traversal, it contains two types. One is breadth first search and depth first search, BFS and DFS. First, what is breadth first search? A graph traversal algorithm that explores all the vertices at the current level before moving on to the next level. Depth first search, DFS. A graph traversal algorithm that explores as far as possible along each branch before backtracking. Weighted graph. A graph in each edge is assigned to a number or weight is called a weighted graph. Cyclic graph, a graph that contains at least one cycle is a cyclic graph or closed graph. Connected graphs. A graph in which there is a path between every pair of vertices is called a connected graph. Disconnected graph means a graph with at least two vertices that do not have a path connecting them. So it is called disconnected graph. Adjacency matrix. A 2D matrix where the presence or absence of an edge between two vertices is indicated. Adjacency list. A collection of lists or arrays where each vertex has a list of its adjacent vertices is called adjacency list. Spanning tree. A subgraph of a graph that includes all the vertices and forms a tree without any cycle is called an adjacency list. It means the directed graph means if all the edges have a direction, it is called a directed graph. A directed graph means let us consider the values v1, v2, v3 and v4 and v equals to v1, v2, v3, v4. That means v means number of vertices. E means number of edges. E means v1 to v4 is the one edge, v3 to v1 is the one edge, and v4 to v3 is another edge, v2 to v4 is another edge, and last v1 to it is the another edge. So it is the directed graph. Weighted graph means a graph G is termed as a weighted graph if all the edges are labeled with some values or called weighted graph. Such type of graphs are called weighted graphs. Let us consider the graph v1, v2, v3, v4. v1, v2, v3, v4 are the vertices. It contains a numerical value that means cost of the graph. So it is called weighted graph. The numbers assigned to the vertices is called the weighted graph. Neighbor vertex or the adjacent vertex. A vertex vi is adjacent to another vertex to vj if there is an edge from vi to vj. So it is the adjacency vertex. We consider v1, v2, v3, v4 are the edges. v1, v2 are the adjacent vertices. So it is the definition of adjacent vertex. Representation of a graph. Let G of v comma e be the SOP graph and mod v equals to n, then the adjacent matrix of a graph is denoted by A of G. A of G equals to mij into n into n. Where vi and vj are the adjacent vertices, then the value is 1. And vi and vj are not the adjacent vertices, then the value is 0. The last content is graph representation. Here we can see the 3 types of graphs and 1 type of tree. First one is undirected, and second one is directed, and third one is iterated. Fourth one is a tree. If the graph is said to be an undirected graph, if no edge have a direction. Here we can see the graph diagram. Here there is no direction between any of them. Whereas second one directed graph, if all the edges have a direction, so it is a directed graph. Weighted graph means let G be a connected graph. And these have the connections 1, 2, 3, 4 have the connections. Then G is said to be a weighted graph if every edge in G is associated with a real number called weight of the edge. The sum of the weights of all the edges in the weighted graph is called a weight of the graph. A tree is a nonlinear data structure. It is a collection of nodes. In that specially designed node is called a tree. The starting node is a root in a tree. How to store a graph data structure in memory? To store the graph data structure in memory is three ways. First one is set representation, and second one is linked list representation, and third one is layout matrix representation. First one, set representation means set representation. In this representation, we use a set to store the vertices and a list to store the edges. The set contains all the vertices of the graph and the list contains all the edges of the graph. This representation is not very efficient for large graphs, but it is easy to implement. Here we can see the example of set representation. Internal implementation of set data structure. The elements are 5, 4, 10, 12. We are arranging the given values in a tree form. So, in order wise, we can see the array representation 4, 5, 10, 12, self-balancing. The second one is linked list representation. In this presentation, we use an array of linked lists to store the edges. Each element of the array represents a vertex, and the linked list at that element contains all the vertices that are adjacent to it. This representation is more efficient than the set representation for large graphs. Here we can see the example of linked list representation. A contains data and null contains next. B contains data and null contains next. It is the linked list representation. Next one is matrix representation. In this representation, we use two-dimensional array to store the edges. The rows and the columns of the array represent the vertices and the elements of the array represent the edges. If there is an edge between vertex I and vertex j, then the element at position I, j in the array is 1, otherwise it is 0. This representation is more efficient than the linked list representation for dense graph. Here we can see the example of array representation in the matrix form. Here we can see A, B, C, D, E. So this is the matrix form of array representation. Thank you guys.